In this lecture, we're going to study about automatic internet setup using DHCP, which is Dynamic Host Configuration Protocol. Now, when you go and select that icon on the top, which is the automatic mode, basically you're selecting DHCP. It's not written DHCP, but that's the technology that makes it possible. Basically, what are you going to do? Well, in the former lecture, you saw all the functions of what is in here. All these numbers that we have in here, what they do, and how they help the internet connection. Basically, DHCP does all of those automatically. It receives all of this information in here automatically from a DHCP server in the local network. Now, DHCP enables a computer or a smartphone to automatically contact the local DHCP server and request for an IP address, networking parameters to connect to the internet. Now, first, the requirements are a local DHCP server must exist. Just because you clicked on that button does not necessarily mean that you're going to get DHCP services. You have to have a local DHCP server supporting you. If you have it and you click on it, then everything automatically will happen. Next, when DHCP is used, setup is automatic. There is no need to contact the local network administrator to have the internet connection set up manually. In addition, this is why mobile devices commonly use DHCP. In addition, DHCP is used for IPv4 and IPv6 connections. Now, DHCP services are used to enable internet access. The DHCP server dynamically assigns the following information, as the IP address, subnet mask, default gateway, as well as the DNS server's IP address. And there's more to it. Now, the importance of DHCP, well, DHCP is so easy to use. It's all automatic. It's wonderful. And DHCP enables reuse of IP addresses. So if there's a pool of IP addresses, then it can dynamically assign, and when the service is no longer needed, take it back and reuse these IP addresses very effectively. So with a small number of IP addresses, you can serve a lot of people based upon their needs when they need it. Now, only a computer or a smartphone that needs internet connection at that time is assigned an IP address to use. After the internet connection ends, well, that IP address is returned back to the server, and someone else can use it. So therefore, it is very effective for subnets. Reuse of IP addresses is especially important for IPv4 networks because there is a shortage of IPv4 addresses. Why? Well, it's like this. An IPv4 address is 32 bits. So if you see how many possible address combinations you can come up with, well, 2 to the power of 32 is a number that is slightly less than 4.3 billion, which means that you have less than 4.3 billion IP addresses. But then again, a lot of the devices like today that we have, for like your smartphone, like I shown you earlier, it has multiple interfaces, and therefore even a single device may need multiple IP addresses. And later on, as I'll show you, in addition, the network needs a destination address. The broadcasting will need a separate IP address. And also the router interfaces will also need IP address assignments. So therefore, much more IP addresses are needed. And therefore, basically, we already have more than 4.3 IP address needs. So therefore, there is already an exhausting problem that we're running out of IPv4 addresses. And DHCP helps magnificently in this aspect. Now, currently there are much more than 4.3 billion. So therefore, this becomes very important. This is why DHCP is needed. In addition, that is one of the major reasons we needed to change to IPv6, such that we had not a 32-bit, but a 128-bit address, which gives us much more address combinations such that we will not run out of IP addresses in the near future. DHCP operations are the next thing we need to look into. Now, DHCP operates on a client-server model. The client is your PC, your laptop computer, your smartphone. And the server is the DHCP server. Now, the basic operation is that the DHCP server manages a pool of IP addresses, in addition, client information, which include default gateway, domain name, name servers, and time servers. The way that the setup message and the operation works is, first, the client connects to the network. Then, DHCP uses UDP to find the DHCP server. The client DHCP program broadcasts a server discovery message requesting for network information. Any DHCP server on the network can provide service by replying an IP lease offer message to the client. And then the client will send an IP lease request back to the DHCP server. That DHCP server will send back an IP lease acknowledgement enabling use of an IP address and network parameters for a limited time duration. If we were to summarize the operations between the client device, which is your smartphone, your PC, your laptop computer, then how does it work with the DHCP server? Well, first step is server discovery. Next step is IP lease offer comes back from the DHCP server. And then an IP lease request is made to the server, and an IP lease acknowledgement conceals the agreement such that the operations are now in work. Next, we look at when a client tries to reconnect to the internet, what happens? If a computer or a smartphone needs an IP address again, the DHCP server tries to give the same IP address that was used before by that computer or that smartphone. However, that may not always be the case. A different IP address may be assigned if that IP address is being used by some other device or due to the network administrator's assignment regulations. In other words, we may prevent giving a device the same IP address just for security reasons or something like that. And therefore, we really don't know what's going to happen until we really look into the DHCP server policies of how it's actually managed. Now, in the next lecture, we're going to look into the IP gateway and router configuration. We're going to focus on the IP address assignment and subnet mask setup part. Thank you.